Hello, ladies and gentlemen. Welcome to our trigonometry part 2. Today we will focus on first prove the trigonometric relationship. For this part, we need to know the trigonometric identities and we learn how to solve the trigonometric equation. Let's go. Sine and cos and tangent, we already learned before and in maths. So these are the things that we already familiar. But in MS, you need to know 3 more trigonometric terms: cosecant, secant, and cotangent. You need to know what is that. So for knowing these 3 trigonometric terms, you just refer to the third alphabet. So cosecant relate with sine. Secant relate with cos. Cotangent relate with tangent. It's just the reverse of sine, reverse of cos, reverse of tangent. So now you already know what is cosecant, secant, and cotangent. Next, we also need to know what is tangent. Tangent is actually equals to sine x over cos x. So cotangent is the reverse of it, so it's cos x over sine x. So if you know this relationship, then we can prove or show relationship. These are the steps that I conclude out. So by using this step by step, it can help you to prove most of the relationship. First, we change everything into sine and cos only. We don't want tangent, we don't want cotangent, cosecant, secant, or we change everything into sine and cos first. Then, if you see any situation like these, they are not in single fraction, so we should join them into single fraction. Okay, third step, we can start to apply rules. 2 most important rules is sine squared plus cos squared equals to 1. Second relationship is sine squared minus cos squared equals to sine plus cos, sine minus cos. So these are the 2 things that we use. But from this relationship, if your sine x throw to the right, so left-hand side left cos squared x equals to 1, you will see this. Okay? Or you can show your cos to the right-hand side, so remain your sine squared on the left. So this major relationship can derive out these 2 relationships. These 2 relationships is important so that we can change cos into sine or sine into cos. But only in square situation they can change. Okay. For second relationship is actually derived from our maths, which is a squared minus b squared equals to a plus b, a minus b. Okay. These things also can use. For example, 1 minus sine squared equals to 1 plus sine x, 1 minus sine x. So these are the 2 major relationships, and we can derive it out for other situations. Okay, so after you know these 3 steps, so let's go and solve some IGCSE questions. So let's go for the first past year question. We need to change these until it's able to form this. So let's see step by step. First step, I say I want to change everything into sine and cos only. Everything in sine and cos already. So this step done. Second step, I need to change it into single fraction. I need to make sure my denominator is the same. For the left-hand side, up, down also I time cos x, cos x. Right-hand side, up, down also I times 1 minus sine x, 1 minus sine x. So the thing that I will get is then I can expand my 1 minus sine x squared will become 1 minus 2 sine x plus sine squared x over 1 minus sine x. If you don't know how to do this, I will write a note here. A minus b squared is a squared minus 2ab plus b squared. Or you can do the longer method. This method 1, this method 2. Boom, 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 boom. You get the same thing, a squared minus 2ab plus b squared. So this is how I get this. Step 2, done. Then step 3, we need to apply the rules. Please go and find whether you've seen these, because this best friend, sine squared and cos squared, will make your equation much easier, okay? So we can see, oh, wow, cos square and sine square is here, and their relationship is plus. So you can join them as 1. So whenever you see a fraction, so usually up, down, you can simplify. Up here, I can factorize out my 2, 1 minus sine x. And can you see? It's just nice to simplify. Then after that, the answers ask us to show 2 secant. See here, which means it's 2 over cos. Perfectly, we prove this. Congratulations, 4 marks. Okay, second question, we try again. Wow, we see cotangent, tangent, secant. Okay, so remember, first step, everything change to sine and cos only. So let's go. Cotangent is 1 over tangent. So cotangent is cos over sine. Tangent is sine over cos. Secant is 1 over cos. Don't scare when it looks very complicated. Just do step 1. Then step 2, we can join them into single fraction. But here is 1, 2, 3, 4, 4-layer situation. Please don't panic and please don't rush to make it in single fraction. We do layer by layer. So we make this into single fraction first. We need to make the denominator same, which so same is go to the upper part. Denominator we times cos, numerator also cos. Denominator sine, numerator also sine. So at last I'll get cos square theta plus sine square theta over cos theta sine theta over 1 over cos theta. Okay, and after that, if you can see the relationship, then you can directly apply the rules. For example, can you see sine square plus cos square? You can directly change it to 1. Then, of course, this single fraction, we must make sure it's in 2 layer only. Here still have 4 layer. So if you're not very confident on how to change it, you do by this first. This divided by this. Then change divide to time. So you get this 1 over sine, which is cosecant. Why? Because cosecant, the third alphabet is S. So it's 1 over sine. You got this format. We try one more. Again, first step, sine and cos only. Then second step, we make it into single fraction. We do from the smaller part. This part, I change them into single fraction. This part, I change them into single fraction. I times sine theta times sine theta. Then 3 layer, I change it back to 2 layer first. If you already know how to change it directly to this is the step that you can skip. But if you're not confident, just step by step. This is an optional step. Next, these 2 things, I need to change them into single fraction. This side, I times 1 plus sine theta. This side, I times 1 minus sine theta. This is when I expanding it. Here also I expand. This and this will become 2 sine theta. This and this will become nothing. And then this thing, 1 plus sine, 1 minus sine is a plus b. A minus b is a squared minus b squared. We successfully simplify until here. Okay, so after successfully make it into single fraction, we do the last part, which apply rules. And here, 1 minus sine square is we derive from here. So this part is cos square. Then they ask us to split into 2 parts. Cosecant is 1 over cos. Tangent is sine over cos. So cos square, I take 1 cos here. 1 cos, I put it here. Then it's just nice. Successfully prove these identities. Finally, we reach the last part of trigonometry, which you need to know how to solve trigonometric equation. We try the easiest equation first. So for this equation, what is the first step we need to do? We need to left the trigo and its baby only. So these two is the thing that I don't want to keep it on the left. So I leave trigo and the baby. Baby is the things that belong to our sine cosangent. So these two throw there will become 1/2. So this is our first step. Second step, in trigo, you need to identify how many quadrants have answered. Usually in 360 degree, which is one complete cycle, we will have two answers. So you must familiar with A, S, T, C. The sequence must be correct. We start from positive x-axis and then turn anti-clockwise. And then the first quadrant is A, which means all sine, cos, tangent will give you a positive value. Then we turn to S. S means that only sine give you positive value. Then we go to T. T is only tangent give you positive value. And last, C. C means only cos give you positive value. So we always refer to positive. Then of course, as much as MS student, you should know where is the negative. So if here sine is positive means tangent and cos is negative. Agree or not? If here tangent is positive means sine and cos negative. Cos is positive means sine and tangent negative. So here is all positive means nothing is negative. So from our equation, we need to identify which quadrant have answers. So they say sine on this baby is positive 1/2. So we check our ASTC. Our sine is positive, so answers fall in these two quadrants. So second step done. Next, we need to calculate the angle. So you need to confirm whether the question asked in degree mode or radian mode. So after the question, they will list down whether this is degree or radian. For example, my x is in between 0 to 360 degree, means that you must key in degree mode. Make sure your calculator in a correct mode. So we just show our sine to another side, become shift sine of half. You get is 30 degree. List down here 30 degree, 30 degree. Make sure there are two answers. The first answer, we always start from x-axis turn anti-clockwise. So the first angle is 30 degree. The second answer, boom. From here go here is 180 degrees minus 30 degrees. So it's 150 degree. So we successfully get the two angle. So let's deal with the baby. Okay, so baby, the 3x minus 1 slowly show. So minus 1 go there, become plus 1. Everything divided by 3. So this is my two answer. At last, we need to adjust based on the domain. We need to check whether this angle and this angle fulfill the criteria or not. So if yes, then we accept. If no, then we reject. Until here, we are teaching the 5 basic techniques. Later, we'll go to different type of questions. We'll see one by one so you know how to adjust your 5 steps. Now we will go for the first IG's question. Level 1 question, I only use my ASTC, then I can get the answer. First step, we left trigo and its baby only. It means that these two I need to show. Step 1 done. Step 2, identify the answer on which quadrant. According to ASTC, my sine is a positive value, so my answer is here and here. Then I shift sine and get the answer, pi/3. Remember, the angle must put in between my x-axis and my line. So I can put all the answers that fulfill the criteria. The first answer, we count from x-axis, turned anti-clockwise, pi/3. Second answer from here comes to here is pi minus pi/3. So it's 2 pi/3. But some students might ask why my calculator do not give me pi/3 but give me 1.047. Okay, it's actually the same. Since the question do not force you to write your answer must be in the term of pi, you can also use this. So your first answer is 1.047. Second answer is pi minus 1.047. Calculator will give you the answer as 2.09. Then at last we deal with the baby. I want what is the value of x. So I show my plus pi/4 to another side, become minus pi/4. So I'll get my first answer is pi over 12. Second answer is 5 pi over 12. If I use the decimal one, I will get 0.262 and 1.31. Remember, if you write in decimal, make sure at least 3 significant figure. If you only give me 2 or 1 significant figure, you are not accurate. And last, based on the domain to do adjustment. So the domain given is here. So they want the answers from 0 to pi. This thing is actually smaller than pi. This thing also smaller than pi. So both answers are accepted. Second past year question, we try something that we can directly use ASTC to solve, but this question is slightly different. Oh my God, if you have sine power 1 and cos power 1, how should you do? So you must make sure sine and cos change to only one type of trigo. So you can directly key in calculator. We know that tangent equals to sine over cos. We throw down cos. So become. So this thing, we can change it to tangent to x. So when we have tangent, the left trigo and its baby on the left only. So we throw my 4 to the right. So step done. Second step, identify how many quadrants we have answers. So tangent is a negative value. We know that tangent is positive when it's A and T. So tangent is negative when it's another 2 quadrants. And key in calculator, my advice, do not key in this negative value. This negative value just for you to identify your answer is these 2 quadrants. So we key in shift tangent 5 over 4. So to ensure my answer is always an acute angle. So the angle I get is 51.3. We start from x-axis, we turn anti-clockwise. So the first answer is 180 minus 51.3. You get 128.7 degree. Second angle is from here, keep turning until here. It's a complete cycle, minus 51.3, 308.7. At last, x is 64.3 and 154.3. And then adjust based on the domain. Both also fulfill 0 to 180. So both answers accepted. Done. Third IG's question that we use ASTC can directly solve it. Before we go to the step, you need to ensure one trigo and maybe on the left. But here we have secant and cosecant. So we do adjustments based on the third alphabet. We know that this is 3 over cos y. This is 4 over sine y. Whenever we will see sine power 1, cos power 1, then we can simplify them into tangent. So sine we throw here become 3 sine y over cos y equals to 4. This part we can change it to tangent. Then trigo and its baby on the left, others on the right. Next, we identify it's on which quadrant. Tangent is a positive, means here and here. Then this is a degree. Make sure your calculator in degree. You get 53.1. My answer is 53.1. Second angle is 180 plus 53.1. So you get 233.1. Both answers fulfill from 0 to 360. Then we successfully reach this answer. Next level 1 question again, it's not single trigo, so we must combine them. So tangent and sine, how to join them? You change tangent to sine over cos. So 3 sine 2y over cos 2y equals to 4 sine 2y. Then I remove denominator first. My cos 2y actually become times. Some student will say, teacher, can I directly remove my sine 2y? No, no, no. When it is trigo type question, do not simplify any value. So how we solve it? We throw everything to one side. Then I do factorization. There is a common factor which is sine 2y. So I factorize out. If something times something equals to 0, then it's either the first thing equals to 0 or the second thing equals to 0. Then we can solve both parts. So if both parts we need to solve means we need to apply 2STC. We check how many quadrants have answer. Sine is 0. We assume it's a positive, so it's here and here. Here we need to do some adjustment. Minus 3 over minus 4 is actually a positive. So cos is a positive, means here and here. We solve this first. Shift sine 0 will get 0. And this is radian mode, so it's 0 radian, 0 radian. So my first angle is 0 radian. Second angle is pi minus 0 radian, so it's pi. So my y is either 0 or pi over 2. And then adjust based on the domain. The domain says I want from 0 to pi, so I shouldn't take my 0. Next, we solve this part. I'll get 0.7227, 0.7227. So my first angle is 0.7227. My second answer is until here, so one complete cycle minus this, so it's 2 pi minus 0.7227. Why use 2 pi? Can I use 360? Cannot, because this question is everything count in radian mode, not degree mode. So 2 pi minus 0.7227 is 5.56 radian. So at last, my y is 0.361 and 2.78. So y equals to. Congratulations, successfully gained these 5 marks. So after successfully learn level 1 question, next we go to level 2 question. Turn more round. Means instead of ASTC, we might need to turn extra round. How to do this? Let's see this question. First, the cotangent, we change it to tangent. Then the thing that I need to find, I need to make sure is numerator, not denominator. So both sides I flip upside down. So we successfully done part 1. We left trigo and baby on the left only. Then we identify which quadrant have answer. Tangent is positive. So key in calculator, shift tangent 205, I will get 21.8. So my first answer is 21.8. Second answer is 180 plus 21.8. Now get my answer is negative 13.5, 166.8. So we check. They want from 0 to 360. So my first answer is a negative value. People want negative or not? They don't want. So what can we do? We reject them because they do not fulfill the criteria, okay? So this 166.8, yes, we accept. Next thing, can you see this 166.8 is very, very far away from 360. So it's very, very possible for us to have one more answer. Trigonometry, we can continuously turn. So we can actually turn one complete cycle 360 degrees, then come back to the first line. So what does this mean? Means that the two angles that we get from ASTC graph, we can add one more round plus 360. So 21.8 plus 360 will become 381.8. And then if minus 35, we will get 346.8. Oh my God. This value also fulfill the criteria. So make sure you include this in your answer. And then some students ask me, teacher, should I add this thing with 360 also? You can try, but you will know the answer is larger than 360. Because can you see this answer already super close to 360. But if you want to try, also can. If you are not experienced enough, then please go and try. So you get it is 525.5, which already exceeds 360. So we reject. At last, I have two answers. Very good. So can you see, move more rounds is required. This is level 2. We try second IG questions that we need to move more around. First, we change everything into sine, cos, tangent only. So this thing we change to 1 over sine. Then swap upside down for both sides. Then I know that sine is a positive value. Sine is a positive, is here and here. Then shift sine 1 over 2.5 is 0.412, 0.412. So I know my first answer is 0.412. This is radian. So instead of using 180 minus 0.412, we use pi minus 0.412, 2.73. Slowly deal with the baby. So we'll get the first answer. We check whether it fulfills the criteria. Oh no, it's again negative. So remove it. Bye-bye. Second answer, 0.910. Yes, fulfill the criteria because pi is 3.14 something. So can you see my answer very far away from the maximum that they request? So we need to try whether it can turn one more round. Here is the radian. So instead of plus 360, we must plus 2 pi. And then which row should we use? We need to use the angle immediately we get from the ASTC graph. So 0.412 plus 2 pi is 6.695. This thing plus 2 pi will become 9.013. So both thing I minus 1. And then both thing I divide by 3. And both answer smaller than 3.14. So both answer we need to accept. Do you think we need to turn one more round? Turn one round is plus 2 pi. Turn two round means plus 4 pi. So 0.412 plus 4 pi will become 12.98. So minus 1, 11.98. Divide by 3 is 3.99. Oh, it's already exceed 3.14. So reject. Then we do not need to continue count other values. So these three answers is my final answer. So B equals to 0.914, 1.865, and 2.67. Congratulations, you scored this 4 mark. So next we go to level 3. When you see answer that they request include negative region, we only do slight adjustment at last. The front part is exactly the same. So as usual, we have cos power 1 and sine power 1. We change it to tangent. We make our cos go down, so become sine over cos. So we can confirm tangent is positive. Is here and here. In calculator, we found that our 3x plus 1.2 is actually 0.615. So my first positive angle is 0.615. My second positive angle is boom, pi plus 0.615. I will get 3.757. And then both minus 1.2 will become, and then everything divided by 3 will get. Remember, both also must be in 3 significant figure, and then we check negative 0.195. Does it fulfill the criteria? Yes, because I want from minus 1.5 to 1.5, and then this positive value also accepted. This 0.852 is quite far away from 1.5, so to double confirm, we try turn one more round, which is plus 2 pi. So this part plus 2 pi, I will get 6.898. And then everything divided by 3, I'll get 1.899. But unfortunately, this value already more than 1.5, so we reject this part. So we do not need to continue the positive turning. So next, this is our official level 3, which is the negative region part. Negative angle means that from x-axis, we need to turn clockwise now. So what is this angle? This angle is pi minus 0.615. You get 2.53. And then because it's turned opposite direction, we must put negative after we successfully count the value of this angle. Divide by 3. Also within negative 1.5. So yes, you gain one more answer. Then we try the second negative angle. Boom. So this thing is 2 pi minus 0.615. So it is 5.67 radian, and its opposite direction put negative. So will be, and divide by 3. Oh, unfortunately, it's already more than 1.5, so we reject this. So our x value is negative 1.24. Done. Some student ask me, teacher, it go negative. Can I just minus 2 pi for my first two angle? No, cannot. For negative region, negative region, negative region, negative region, you must count the size of angle. Next, we go to level 4. Level 4 questions, all 4 ASTC quadrant will have answer. So there are two situations that's special that all 4 quadrant have answer, which first situation is when you see modulus situation. Second, when you see square situation. Let's see one by one. First question, this is about the modulus question. So as usual, we show the 2 to another side first. Then when we remove modulus, make sure you have positive and negative 1/2. So sine positive is here and here. Sine negative is here and here. So that's why all 4 quadrants have answer. Then this question is radian. We shift sine half, we will get pi/6. So the first positive answer is pi/6. Second answer is pi minus pi/6. 5 pi/6. So the third positive is pi plus pi/6. Oh, but you see, this thing already more than pi. So that's why we do not use this third positive answer. Then we are finding the negative part. First answer is pi/6 go opposite direction. So answer is negative pi/6. Second answer is pi minus pi/6. So is 5 pi/6, but it's negative direction. So negative 5 pi/6. The third negative answer are also more than negative pi. So we will accept 1, 2, 3, 4 answers. Next, we try the square question. We change cotangent to tangent first. Then our unknown put up. So we throw our square to another side. Remember, when we throw our square, it will become plus minus square root. So because of this, tangent include positive and negative square root. Tangent positive is here, tangent negative is here. So that's why all 4 quadrants will have answer. We get pi/3. So the first positive is pi/3. Second positive is 2 pi/3. Third positive is 4 pi/3. Fourth answer is 5 pi/3. So everything we plus pi/3 and everything divided by 3. So you get all 4 answers, and then all 4 answers between 0 and pi. But they don't want pi, no equal sign here. Please remove this, so you have 3 answers. So until here, we already do all 4 types of situation. Hope that this will help you to master how to solve the trigonometry. So we already complete the basic part of trigonometry. Of course, we have 2 more parts. One is if we cannot use calculator, how to count. Second is other than sine square plus cos square, if you see 2 more special equation, where will we use that? So these 2 balance part, we'll do it as part 3. So stay tuned. Please subscribe, like, comment, and share this video to your friends. Thank you.